Hello, in this video, we're going to continue learning about adding and subtracting mixed numbers and improper fractions with unlike denominators. In the previous video, you guys learned how to add mixed numbers using a visual model. You learned how to add mixed numbers following the normal standard algorithm, keeping these two fractions as a mixed number, and you also focused on areas when we can change this mixed number to an improper fraction and then solve. You also learned that subtracting and adding mixed numbers, you do the same process by changing the denominator so that they are the same number, and you are using equivalent fractions to do that. You learned that whether you add or subtract, it's still the same process. You're looking at the whole numbers, you're looking at the numerators, and determining what is my operation symbol. Am I going to be adding or subtracting? Now, the rest of this video is going to focus on two word problems. The first word problem says, Miss Lot walked 2 1/3 miles in the morning and another 3 1/4 miles in the afternoon. What was the total distance she walked? Now, both of these problems we're going to focus on today. I'm going to solve them using mixed numbers and then using improper fractions. So, what was the total distance? These are keywords that are telling me that I'm going to add these two mixed numbers together. So, in the morning, Miss Lot walked 2 1/3 miles. In the afternoon, she walked another 3 1/4. So what is the total? We're going to be adding these two numbers together. The problem is I look at my denominators and I say, wait, they are not the same. Let me write these out, 3 and 4. Let's start by listing out my multiples. Some of you at this point might even be able to recognize what my least common denominator is. But if you can't, it's totally okay to list out my multiples. So I have 3, 6, 9, 12, 15, 4, 8, 12. And I'm going to stop there because I recognize 12 is in fact my least common multiple. So let me list out 12 as my denominator. This is great. I found my least common denominator. I see that now I have a whole number. Let me just simply include that here. And now let's determine what my new numerator is going to become. So 3 times what number gives me 12? Well, 3 times 4 is 12. So if I multiply my denominator by 4, I do the same to my numerator. So 1 times 4 is 4. Now I look at my denominator. 4 times what number is 12? Well, 4 times 3 is 12, so 1 times 3 is 3. Notice I multiplied my numerator and denominator both by the same number. So now I look at my mixed numbers. I see my denominators are the same. I found equivalent fractions, which changed my denominators so that they are in fact the same. Now, the beauty of equivalent fractions is we know that 3 1/4 is equal or equivalent to 3 3/12. Now, I simply add my numerators. 4 plus 3 is 7, and I can't forget about my whole numbers. 3 plus 2 is 5. So Miss Lot walked the total distance of 5 7/12 miles in one day. It's a lot of miles. Now, I'm going to take the same exact problem. I have 2 1/3 plus 3 1/4. I'm going to change this to an improper fraction. 3 times 2 is 6, plus 1 is 7/3. You can also draw a visual model like we did in the previous video to help you determine this as well. So now I have 3 1/4. 4 times 3 is 12, plus 1 is 13/4. But I'm like, wait, my denominators are not the same. Fortunately, same denominators as when it was a mixed number, so same least common denominator. How great is that? We already have the work. So now let's determine this. 3 times something gives me 12. Well, 3 times 4 is 12. So 7 times 4 is 28. Now here I have 4 times 3 is 12. So 13 times 3, and if you have to write this out on the side, that's totally fine, is 39. Now I have my same denominators, which are 12. I can simply add my numerator. So if you need to write out 39 plus 28, that's absolutely fine. So now we have 17, 3 plus 2 is 5, plus 1 is 6, giving me a final answer of 67/12. Now, you can solve this problem both ways. However, if I was to go explain to my family, this is how much I walked today, my family, if I told them I walked 67/12 miles today, they're going to have a hard time understanding the total distance I walked. However, if I explain to my family I walked 5 7/12 miles, they have a little bit better of an understanding. 5 7/12, that's about 5.5 miles, and 5 miles, even if they ignored the half parts, you still understand, okay, approximately between 5 and 6 miles I walked. Now, explaining that number to somebody is much easier for anyone to interpret than explaining I walked 67/12 miles in the day. That's why, depending on the problem, you might want to select, are you going to represent your final answer as an improper fraction, or are you going to choose to represent it as a mixed number? Now, if I was going home to my family and explaining to them, I'm going to walk, this is how much I walked today, I would definitely use this mixed number to explain the total distance I walked in a day. Next problem here, during a blizzard, it snowed 15 7/10 inches. After a week, the sun melted 8 1/2 inches of snow. How many inches of snow is left? So let's see here. During the blizzard, it snowed 15 7/10 inches of snow. After a week, the sun melted. That means it disappeared. We took away the snow. Okay, that's telling me I'm going to be subtracting 8 1/2 from 15 7/10. How many inches of snow is left? Keywords. Okay, keywords for subtraction, finding the difference. So I'm going to subtract these two mixed numbers. Before I start subtracting, I recognize that my denominators are not the same. Okay, so let's list out my multiples. 2, 4, 6, 8, 10. Wait, 10 and 10? This is great. That means 15 7/10 can stay exactly the same. But now I want to do something. I need to find an equivalent fraction to 8 1/2. That's showing me it's equal, but my denominator is going to be 10. So I recognize that 2 times 5 is 10. So I'm going to take that same number and multiply that to my numerator. So 1 times 5 is 5. Now, instead of adding this problem, I'm going to subtract. But notice it was the same process up until I need to actually do the operation. So now I notice my denominators are the same. 7 minus 5 is 2. And now 15 minus 8 is 7. So that's telling me that how many inches of snow is left is 7 2/10 inches of snow is left. Now, this is a popular number here. In fact, if you were to ever ask, Alexa or anything else how much snow there is, you will oftentimes hear them use tenths. And the beauty of tenths is you can also convert this to 7 2/10 is the same as 7 2/10. So oftentimes on the news, if you're listening to the weather, you're asking somebody for the weather, they might actually use tenths to describe how much snowfall there is, how much snow is left, how much is left in a certain area. So these denominators and this value is used very often in the real world. Now, 7 2/10 is telling me, okay, there's about 7 inches of snow left. That's how much is left after the blizzard. But as always, you can also do this as an improper fraction as well. But notice it's going to be a little bit larger. So if I have 15 7/10 minus 8 1/2, okay, the first thing, let's convert this to a mixed number. So you get 10 times 15 is 150 plus 7 is 157/10 minus 16 plus 1 is 17/2. So 157/10, you can leave the same. We want to change 2 times 5, give me 10. So 17 times 5, let's write that on the side if you need, no biggie if you have to do that, is 85. Now notice here, by doing it, solving as an improper fraction, you're still doing the right process, just your numbers are a lot larger. So now I'm going to subtract my numerator, 157 minus 85. So let's subtract, we borrow here, and we're left with 72/10. Now notice here, 7 2/10 is equivalent to 72/10. But if you're describing how many inches of snow is left, are you going to describe, hey, there's 72/10 inches of snow left in my backyard? probably going to use 7 and 2/10. It's a little bit easier to understand when you're representing this answer as a mixed number. If you choose to leave your answer as 72/10, that is still correct, and that's absolutely fine. But when we're looking at these word problems and you're explaining to your family, okay, this is how much snow is left, saying 7 and 2/10 is a much easier way for somebody to interpret that answer. So, as always, you can refer back to this video at any time to help you when adding and subtracting mixed numbers and improper fractions with unlike denominators. I hope you enjoyed these two real-world examples and have a better understanding on how to solve problems just like this.